Hello. Okay, so now let's get started. So in the last session, we discussed about the Docker containers and all the things. Now let us discuss about the main and most important concept of Docker. So that is how containers will be created and how containers will be running. So today also we'll have a very little session, and from tomorrow onwards, we are going to have the main concept. Okay, so whoever are there, so this is the last and final demo which we are going to have. And from tomorrow onwards, you will have to join with a premium link. Right. So now let us discuss about what is what and how containers will be running inside a Linux operating system. What is going to happen in the backend. Now, if you can see here, so in Linux environment, every running application is a process. Not only in Linux environment, in any operating system, everything is a process. Okay, so the application which is running is a process and its dependencies is a process. Like that, everything, whatever you are seeing here, everything is a process. Now, in the same manner, containers, whatever are running on a Docker environment, containers are also the process that will run the application and its dependencies. So excuse me. So containers are also a process running in a Linux operating system. Okay, this is fine. How you are going to prove that containers are the Linux processes? So to make sure you understand this concept, what I will do here is I already have a Docker server created in my AWS environment. Here you can see we have a Docker server running. Okay, so let me log on to that Docker server. So hold on. I'm going to restart this session. So once again, wait a second. Okay, let me copy the public IP. Go to the putty, status, load Ubuntu at the public IP. So I'm able to log on to my server. So inside the server, Docker is already installed. To make sure that you understand this, so now what I will do, Docker PS. We are having certain containers that are running. So now what I will do here is, what I am saying. So PS, whenever you give, PS is a command which you have to give to know what are the processes that are running in your Linux operating system. So here you can see in the Linux operating system, the processes that are running are Docker PS. Okay, so here when we give the Docker PS command, it is showing me the container related information. In the same manner, if I give ps-ef, so here also I'm going to get the what I can say processes that are running on your Linux operating system. So now what I will do here is ps-ef grep docker. Here you can see we have Docker related application. So this is a Docker related application. This is a Docker related service processes that are running in your Linux environment. What are these two processes actually mean to? So let me show you one thing. Here you can see this is the actual Docker process which is running. So 2432 is the actual Docker process. Let me do one thing. I will make sure that this will show a little bit low. We'll go to 12. Good. So ps-ef grep docker. Here you can see we have 2432. So here the first one is, this is called as the process ID. Whatever you say, this is the user. Who is the user that is running this process? This process is running by the user root, and this is the process ID, and this is the parent process ID, and this is the command which is running the process. So right now we are having a process called as Docker. So this is the process ID of the Docker. Now, if you can see here, we are running two containers. We are running a container. The container is having a process 5955 and 5960. These are the two processes that are having for this container. Okay. So if you see here, let me show you what is the container that is running in your Docker environment. Docker PS. There are two containers that are running. So I will stop both the containers. Docker stop, or else let me do one thing to make sure you understand this. Tmux, I'm going to divide this terminal into two terminals. One is with the help of a command called as tmux. So Control B, Shift double quotes. If you press this automatically, the terminal will be divided into two terminals. Control B, up arrow, watch -n1 docker, sorry, ps-ef grep docker. If you give this, if you give this, look at that, we are having two processes that are running. So what is the parent process? The parent process is 2432. The parent process is 2432 in the sense, this is the command which we are using to run the Docker application. So how you can say that this is the command, sir? So what I can do here is nano. So let me come down, nano /etc system. There is a Docker service file which will be created in this particular folder. Docker, or else let me first of all go inside this cd ls. Here there should be a docker.service should be created. So let me check out that once first. Let's see, system active.service is there in the same manner. SSHD service is there. There will be cd, or else let me do one thing. Find /name docker.service. If I give this, it is going to find out the Docker service file. Anyways, the Docker service file will be maybe available in /warlib docker. Let me go into this. ls container somewhere. It should be there. Where it is? Okay, I will see that user bin docker. Okay, so actually your Docker will be installed over here. Okay, so we are running this Docker on this particular application. So we are having a docker.service will be created, and from that service file we are going to get this. So systemctl status docker.service. If you give this, then it is going to show you the status. So here you can see where is this lib systemd. So I said, so somewhere it is there. I will show you that. So the Docker is actively running. So what is the command it is using? It is using the command this one. Okay, so this is the parent command. Okay, to run your Docker, this is the command. So which means that which is running on the process ID 2432 in your Linux operating system. So what you need to understand here is you will have a Linux operating system installed on the top of your hardware. So there is a Linux, for example, this is your Linux operating system which is installed on the top of your hardware. And on the top of that, we are running the Docker application. So the Linux operating system will see every application as a process. So this particular Docker application is having a process ID 2432. So this is the process ID of your Linux operating system. I mean the Docker environment. So the main Linux kernel will have one as a parent ID. So don't worry about this, but this is the process that is running. On the top of this process, so as taking this as a parent process, on the top of this process, we are having a container. So the container is running on the process ID 95955. 5955. 5955. So this is the container running application with the process ID. So clearly we can say that container is a process in your operating system. To make sure you understand this, let me do one thing. cd/lib system and system. So here there is a docker.service nano docker.service. If you go into the service file, here it is clearly given the description. Okay, we have to start the Docker by running this command. Look at that. We have to start the Docker by running this command, and we can restart the Docker by using this particular command. So these commands will be given in this particular service file. So that's okay. So now what is my requirement here? I want to make sure you understand. So there are two containers that are running on your Docker environment. So I need to prove that these containers are the processors. So how I can prove that these containers are the processors? So look at here. These are the two process IDs that are running. Okay. Now what I'm going to do here is Docker stop Nginx. When I stop Nginx over here, what is going to happen? Look at that. The processors are deleted or else the processors are removed. Previously, the process ID is 5955. So, but as we have stopped the Docker container, automatically the processor stopped. Now, let me start the container back. Docker start Nginx. So when I start the container back here, you can see two processes are created, but this time the process ID is different. 19175, 19181. So which means that you can clearly say this, the processes or the containers that are running in a Linux environment are the processes that are running on a Linux environment or the containers that are running in a Linux environment or the process of that particular operating system which is running on your Docker. So this I can clearly say this. Got it? Any questions here? Do you understand the point here? What is the point that you understand here? Guys, can you please unmute yourself and tell me what is the point that you understood here? Anyone? We don't have all day, guys. Please, can you please unmute yourself?
A new process ID will be assigned to the new strategy with that container will be going to start.
First thing what you need to understand here is container is a process. That is the first thing. Process ID assignment or the not assignment, that is not a question here. What is a container? Container is a process. Okay, to every process, definitely there will be a process ID. Don't worry about that. Okay, you need to be concentrating on the process. Okay, good. So now the next one is, now we have the containers. We are having the containers or else how these containers are evolved, how these containers are evolved into the Docker or else how Docker is created. So first things first, what you need to understand here is when you want to create a container, okay, so what will be there inside the container? Whenever a container is created, what will be there inside the container? Guys, from the first class onwards, I am saying you the same thing. What will be there inside the container?
Images.
No. Container will have the applications, right? Whatever the applications that you want to run, all the application will be there inside the container. So now what you need to understand, so whenever you are running an application, so what applications will do? Applications will run. We don't have any problem with the application. They will be running, but they are going to consume the resources. For example, you have created an application in a Docker container and it is running very good. We don't have any problem with the Docker. We don't have any problem with the container. So the application inside the container is running fine. So this application, whatever you hosted on the Docker environment, this application suddenly using the resources beyond its expected resources, which means that I know that the application will only access one CPU, 2 GB of RAM. That's more than enough to run the application. So suddenly what happened? In Java, there is a concept called as memory leakage and certain concepts are there. So what is going to happen? Because of these concepts, suddenly the applications are consumed beyond the expected resources. So I am expecting that the application will consume only 1 CPU, 2 GB of RAM, but the resources are increasing. So when the resources, for example, I'm having a server. Okay, I'm having a server where I have installed the operating system, and the server capacity is somewhere like 8 CPU, 64 GB of RAM. 8 CPU, 64 GB of RAM. Inside this operating system, I am having multiple number of processes that are running. So, or else multiple containers are running. Each container of the application is consuming. Suppose, for example, there are 10 containers. There are 10 containers in your Docker environment, and these 10 containers are the processes that are running in your Linux operating system. Processes running in Linux. Okay, each process is consuming. So by default, each process has to consume somewhere like one CPU, and CPU utilization is a different concept, guys. Don't get confused. Sir, here you are saying 10 containers, which means 10 CPUs should be there. It is not like that. It's a logical way of expanding the CPUs. But don't worry. And then 64 GB of RAM is there. So each container will consume 2 GB of RAM. So 2 GB means 2 into 10, 20 GB they will consume. Or else let us go for 4 GB of RAM. Okay. 4 into 10, 40 GB they will consume, and remaining 2 GB to 4 GB, the system resources will be allocated for the operating system. Now, still you are having 20 GB of spaces, 20 GB of RAM is free for your applications to run. So now what happened here? Suddenly, among these 10 containers, one container is started utilizing not so it has to actually utilize 4 GB of RAM, but beyond that, it is going for some 10 GB of space. And like that, if there are two containers that are having the same, your resources will be closed. So there won't be any resources for allocating to a new container. So now what is going to happen? So the containers are utilizing in so much amount of resources. I don't want that to be happen. Enormously, it is going to utilize. So how I can restrict that? These containers can only access, or else these containers can only have this much amount of RAM, or else these containers should access only this much amount of CPU. So to make sure that that should be happen, we are going for a concept called as C groups. In Linux, C groups are configured to limit the resources of the processes. Whatever the processes that are running in your Linux operating system, we can make sure that this process should consume this much amount of CPU. This process must consume this much amount of RAM. So what we can do, we can limit the processes for the limiting, we can limit the resources for each and every process. In such manner, we can make sure that each and every application is running safely. So that is called as C group. So simply, for example, let me do one thing. What I can do here is Docker PS. Here we are having a container that is created, and let me remove both the containers, Docker rm-f, nginx, and T6. I am going to remove both the containers. Okay, so here you can see Docker PS, we don't have any container. So now what is my requirement? I want to limit the container one, or else whatever the container that I am right now creating, I want to limit that container configuration to 50% of CPU utilization. So I don't want to make sure that the container will use more number of, a huge amount of CPU space. So what I can do here is, let me show you one thing. So if I don't give this command, so what is the command that I'm giving? I'm giving like CPU quota is 50,000. 50,000 in the sense 50% of CPU utilization. But if I'm not giving this, okay, what I'm going to do here is I'm going to straight away I'm going to run a container. Docker run -itd hyphen name of the container is T1, and with the image Ubuntu. So I'm going to create the container with the image Ubuntu. Docker PS. Here you can see a container is running. What is the name of the container? T1. So Docker execute -it. I'm logging into the container T1 and bash. So just now I am logged into the container. So now what I will do, apt update -y and apt install -y stress. I'm going to install a utility called as stress, which will provide the duplicate load on the container. To make sure you understand this, let me go up. just got installed. Now let me do one thing. Docker stats. If you give this command docker stats, so inside the container, what is the container name? T1. So the T1 is using 0% of CPU right now, and memory utilization is this. So let me go down back. So when I give the stress command, let me execute this. Just for 10 seconds, I'm going to give the stress on that particular container. Now look at the CPU utilization. The CPU utilization has gone to 100%. So it is consuming the total 100% of your system CPU, your server CPU. That is what I don't want. I want my container to be utilized. So if it is going beyond the 50%, I don't want the container to go beyond the 50% of the CPU utilization. So for that, what I'm going to do here. Docker commit. What is this commit command? I will tell you. T12. So I'm going to create a container. How I'm going to create the container? Docker run -d. The container name is T2. The container name is T2 with the image stress. So just now I have created an image called as stress version 1. The container got created Docker PS. Or else let me do one thing. I will create with the Ubuntu only. I will create this container with the Ubuntu. Already T2 is there. Let me go with T3. Good. So a container with the name T3 has been created. Docker PS. Why it is not getting created? Hold on. Because ITB. T2, T3. Now T3 container is there. Okay. Or else let me create a T2 container with stress. Just give me a second, guys. Stress version 1 and the container name is T2. Okay, so here you can see a T2 container is also created. But how much amount of CPU? I'm saying 50% of the space. So Docker PS, here you can see two containers are created with the name T2 and T3. Docker execute -it T2 and bash. So I'm going inside that. So if I give the command stress, okay, so what is going to happen? Previously, when I give the command stress, it is using 100% of the CPU for 10 minutes. So here you can see what is the CPU utilization. Is it going beyond 50%? Can you see that T2? What is the T2 CPU utilization? Whether it is going beyond 100%? Look at there. At any given point of time, how much CPU utilization it is going with T2 container? Look at there and tell me how much it is going. The CPU utilization, whether it is going beyond 50% or it is there at 50%. Guys, come on, speak out. You are seeing visually, but you are unable to speak. Come on, speak out, guys. Hello. Hello. Guys, do you understand the concept or can I repeat it again back? We don't have all day. Can you speak out, please?
It's near to it's near to 50%.
It is not utilizing more than 50%. See, if See, one thing I'm very serious about my sessions is if I don't get any proper response from my candidates, I'm going to terminate the session immediately. Okay, it is going to, if it is going to go for a prolonged time also, I don't mind. So I want your responses. If you don't give the responses, then in my brain, I will think like, oh, okay, oh, so the candidates are understanding or also they are not understanding. So there is no necessity of going with the thing. Okay, so my request for you all is I want the session to be interactive session, not a dumb session. Don't sick. I know there are the people who will start the Zoom meeting and they will leave and they will come back again. So I don't want that type of candidates. I want the candidates who are sitting near the system and who are trying to learn something. Why? Because you are investing some 20 days of time and some amount of 5,000 rupees. So invest that for your proper career. When I ask a question, please try to give an answer. If you don't understand, also say that I didn't understand, or else say that say that if you are thinking that's a very silly question, also I don't have any problem to answer all your questions. And eventually you should be what I can say you should be uh, getting the benefit. If you don't get the benefit of the sessions, then it is nothing. So please try to concentrate on the classes. Okay, fine. So now when we coming back to the point here, the point is, so here you can see that T2 is only utilizing only up to 50%. It is not going beyond the 50%. How? Because the control groups are managing that. So the control groups are maintaining and managing that configuration. So so what I can explain you here, control groups are used, whatever the control groups that you are using, control groups are used to manage the resources for your containers that are running on your Linux operating system. And there is one more concept called as namespace. So here the namespaces are used in the namespaces are used to manage or else to isolate your containers, whatever the containers that are running in your Linux operating system. If I want to isolate one container over the another container, see in a session, so in a class, there if you are in a 10th standard or else if you are in intermediate standard, so how a faculty is going to differentiate? Faculty is going to say the same concept. So he will say maths or else physics, same concept he is going to say. The but each and every student is different. How? Because of their names. So this candidate will have his own name so that he will be into this particular environment. So in the same manner, the containers whichever is running, the containers are running on a namespace. Okay, this namespace, actually namespaces are created depending on the process ID of the containers. So each and every container will have a different distinguished and isolated process ID. So each process ID of the container will vary. Okay, so this will represent the namespace. So in general, if I have to discuss about what is meant by a namespace is a namespace is a resource segregative property in the Linux operating system. So one container should be segregated with the or else one Linux container will be separated on the another container with the help of the namespace. So by using the C group and namespaces, we are going to work with the entire container configuration, Docker containers and Docker containers, and as well as your Kubernetes orchestration platform. So the entire Kubernetes orchestration and as well as your entire Docker containers will be depending on these two concepts called as C groups and namespaces. So I hope you understand this concept. So that's it. So in the next session, so of course I already said you the whatever the session that I'm going to take today, that will be a very tiny session. Why? Because I need to merge this batch into the another batch. Okay, so one thing that you have to get clarity about what we have discussed from the beginning. So let us see what we have discussed from the beginning. Can anybody tell me? I know what I have discussed. We have discussed about the on-premises environment versus virtualization, and then we have gone for the Docker environment, and then we discussed about what I can say, and then we have discussed about the C groups and namespaces. So these are the concepts that we have discussed from the last 3 days, 3 sessions, and that's it from my end. If you have any questions further, you can ask me now. Last 5 to 10 minutes are available for your questionnaire.
Hello, sir.
Yes, hello.
This is my first session. Would you be provide recordings of previous sessions as well?
You will get it once you have enrolled for the, or else you can check out in the YouTube also, that is available, I think. Okay, or
Okay.
else just reach out to the DurgaSoft for the recordings, they will provide you. But so my request is that if they call you, at least respond. So I'm not talking to you, I'm talking to everyone. I'm keeping in the mind, so I'm talking to everyone. So if anybody calls you from DurgaSoft or else, uh, in general, they will be calling from the DurgaSoft. They call you, at least give a response. So that will make sure that okay, the candidate is joining. We cannot continuously call you continuously and ask you about your response. Okay, so please respond back. If you are interested, say interested. If you are not interested, we are not interested, so that they won't call you back. Okay, so that you can save your time as well as we can save our time in this. Okay,
Uh,
guys. Yep.
so tomorrow onwards, you are continuing from here, right? You won't just go through a brush up starting of the class.
I won't go to starting the batches. I will go. I will continue from here itself.
Okay.
Wherever we have stopped, from there we will be continuing.
Okay.
Tomorrow class will be 6:30. Is it?
Yeah, tomorrow onwards the session will be at 6:30 a.m.
For the
Okay.
AWS account,
Sorry.
for the AWS account, can you give me the idea about this?
AWS account you have to create and you have to check out that one. So just go through the any YouTube video how we can create an AWS account, but the latest videos, not for uh, just to go through the latest video to create the AWS account. You can find out so many videos. Okay. So in this AWS account only we are going to create our servers. AWS account how to create, and that too not go for 1 year or 2 years, just to filter it out for this month. So here you can see how to create an AWS account. That will be helpful for you, just 3 minutes of time. It's a free tier account which they are creating, and that will be very benefited for you. Okay, so apart from that, after creating the AWS account, we need to launch the EC2 instance which we are running right now. So I have already given how you can create the EC2 instance in the AWS account. You can just go through. Okay,
Thank you.
right. Questions?
Sir, I have one question. In real time, do we always need AWS or in local also we can install Docker?
See, Docker, anywhere you can install, whether you can go with the local system or else you can go with the AWS environment. It is not like you have to go with only AWS environment. It is your wish whether you can go with the local or else you can go with any cloud. I'm not saying that you have to go with the AWS. You can go with the Azure also. But for Kubernetes in perspective, I'm talking about the AWS. Okay, I'm talking related to Kubernetes perspective. When we are going to work with Kubernetes, everything will be hosted on AWS. So that's the reason I requested you to create the AWS account. Am I clear?
Yes, yes.
Right. Docker, wherever you want, you can create the resources. You don't have any problem. I'm not saying that you have to create only in the AWS. Okay, Docker is not a very huge, what I can say, very huge application. It's just a small application. So it's not a point that you have to go with only AWS environment. But for Kubernetes, definitely you need to go with the AWS environment. Why? Because it's a minimum T2 medium servers we want. T2 medium in the sense 2 CPU, 4 GB of RAM. At least we are going with the creation of the cluster. Three servers will be there, so which requires 12 GB of RAM and 6 CPU, which will not be provided by your system. So for that reason, I request you to go with the AWS environment. Am I clear?
Yes, yes, sir. Sir, I have one more question. So, for example, uh, I I have one Docker is there. and we want to install multiple images. For example, we want to install Airflow image, we want to install another different software install. So can we deploy on AWS or GCP?
Images you can create on the Docker first thing. You are going to create the containers on the Docker. So I didn't get your question. Why you want go? Why you want to go for AWS and GCP? What is the necessity for that? You have the images. You can create a container on the Docker, and this Docker will be installed on the server. And the server can be anywhere. Either it can be on AWS, or else it can be on GCP, or else it can be on the Azure. Are you getting the point? So you have an image, and with that image, you are going to, and don't get confused with that. I know, I hope that you are thinking the images that are related to AWS and Docker both are same, but they are different. AWS AMI, Amazon Mission Image, or else for Azure, whatever the images are, for GCP, whatever the images, those images are used to create the servers, not for creating the containers. For creating the containers, we need to create our own images, or else you have to pull the image from the Docker Hub. That is altogether a different one. So when I tell you about the Docker architecture, there you will understand what happens in the backend. But the point what you need to understand here is, so I didn't understand why you bought AWS and GCP in middle. Can you please elaborate that once for me?
Yeah, yeah, sure, sir. So, sir, like for example, I'm working on one project, okay? So where we have some like Python libraries are installed. Okay, so if we are installing that another libraries, like for example, if I want to install the Airflow, okay? So Airflow have their own Python libraries, okay? So there is some conflict happened. So in my team, they have suggested that like what we need to do, we need to take a Docker image, okay, Docker container, and via Docker container you can install Airflow, so that there will no conflict happen, and after that we will deploy that in either in like we are using the GCP services, so we will deploy that
There, there
Docker
comes
images.
there comes the main conflict, main understanding. Here, what they are saying is we are going to deploy that on GCP and AWS, in the sense in AWS or GCP, you are having a Docker server. First thing is that, okay, wherever you want to deploy, you have that Docker server. So they are asking you to test whether that will be running properly inside the container. So where you want to test, you will have your laptop. In the laptop, you will have your Docker environment created. So inside that Docker, you have to check whether the containers are running properly with that image. Okay, so if you go to the Docker hub, hub.docker.com, if you go here, so what is the image name that you have told me? The image name is uh, Airflow. If I'm not wrong, this is the image. So from
Yes,
Docker
yes.
Hub, from the Docker Hub, you can pull out this Airflow, Apache Airflow, and you can run a container. So once you run that container and whatever the dependencies are, if you install all the dependencies and run the container, then the container will be running properly as your expectations, as how you have expected. In the same manner, the container will be running, and you can say that. So whatever the image that we have created and the dependencies that we have run, the container is running fine. So now what they are going to do, so whatever the image that you have created, so you will create a Docker image. Okay, whatever the image that you have created, Docker image, try to understand. So with the help of that Docker image, they are going to create a container in the AWS servers or GCP servers. So right now we are having a Docker server in my AWS environment. Are you able to see this? So in this, I have created a container with the help of Tomcat or Nginx. In the same manner, they are going to create the container with the help of whatever the Python Airflow, or else whatever the application that you are saying. Do you got the point here?
Yes, yes.
Any questions? Is everything is clear? Okay, guys. So we'll meet in the next session. Tomorrow's session will be at 6:30 a.m. So today we will be winding up the things here. Okay. So from tomorrow onwards, we will join at 6:30 a.m. IST. So if there are any people who are attending from another countries, please check out the timing. So I'm talking 6:30 a.m. IST, and take the relevant time as per your time zone. Okay. So I hope you understand the concepts. I hope you are doing well. So tomorrow onwards, we will start the Docker very in deeply. So from the basics, we are going to cover. So that's it from my end. Have a nice day and bye bye. So and one more thing, tomorrow onwards, it will be a paid link. Okay, whoever has registered for the course, they will get a link from the DurgaSoft, and you will be joining into the course. Okay. Yeah, Kunal, you are about to say something.
No, sir. Actually, it's the first day I joined, so I'm joined late. Just it flashed the message. So yeah. So,
Yeah.
uh, yeah, I want
So
to understand more on like what we are going to cover.
that I have already given everything on my introduction concepts. So just to
Okay,
go through the videos that will be provided, if you ask the DurgaSoft, they are going to provide you the videos. Okay.
sure, sir.
Yep. Okay. Fine then. We'll meet in the next session. I hope I see all the candidates in the next session. That's all from my end. Have a nice day and